So one of the things we've always looked at in the ideal of site development, civil engineering, um, stormwater management is this ideal of urban drainage good practices. And today's topic of shaping the future involves AI's role in civil architectures, machine learning with InfoDrainage. But one of the things we often want to be able to do is design for exceedance events in terms of stormwater that has been a remediation and adaptation strategy, um, which kind of mitigates the effects of flooding that is also being applied not only for the development that you may be working in, but the development downstream to see what may be affected by that development in terms of stormwater. So, InfoDrainage, which was acquired maybe 2 years ago by Autodesk, they've um, they've added in some really new functionality in terms of artificial intelligence or AI. And what I want to do is kind of look at the top 10 ways that AI is changing specifically the water industry. So as we go, and Misty already talked about who I am, so it's just a variety of different things with specifically stormwater management, hydrology, and ESRI services. But as you can see, we got a good gambit of different things that I've kind of worked through in terms of my journey over this last 20 years or so. But again, the topic is really specific to AI. And artificial intelligence kind of is making its mark with the water industry, really powering intelligent operations using machine learning to optimize resources, use, and operational budgets for organizations. So, what does that mean in terms of machine learning? So, in some of the examples that we will take a look at for a developed site, pre-developed site, and one of the things is being able to see a detention pond and then, based upon rainwater and flooding, where's the best place to collect that water in terms of placing that detention pond. So the first thing I'm going to do is talk about the 10 ways that AI is kind of changing the water industry, from business innovations to saving money to global water challenges and lowering overall water consumption. So, the first thing, water and wastewater operations kind of investing in artificial intelligence. Market research kind of shows that it's forecasting to be about $6.3 billion in terms of AI solutions by the year 2030. And that investment is really part of a growing trend for the water industry. So go digital, smart infrastructure solutions, things like that. So spending digital water solutions in the United States, Canada, and Europe, again, forecasted for 6.5% annually. And that's outpacing the growth sorts of municipal water and wastewater sectors over the next decade. So that's the first thing. Also, an example of AI in action is kind of predicting sewer flows. Sewer systems are critical in reference to how they transport wastewater to treatment plants. But what kind of impacts are they having on climate change, aging infrastructure? We know in some of the oldest cities in the United States, infrastructure in terms of storm sewers, they have historical age limits, and historical design practices. So too much raw sewage is being released into our environment, causing harm to our planet and damaging properties. But by training an artificial intelligent model with thousands of these examples, the model can learn and predict the next flow value without the need to know the exact processes. So the complexity of digital water solutions and their applications They're kind of highlighted in this screenshot in terms of Bluefield's analysis of the 5 key technologies. So information management, metering and customer management, then network management, work and asset management, and then plant management. And then almost, if you think about it, 92 billion total. So just some things to think about in reference to the water industry in terms of technology. And that was since 2019. But with some of these utilities, these utility companies basically spending like $300 per person or per customer annually on water and wastewater operations. The potential for saving is really significant. And AI can save 20 to 30% on operational expenditures, reduce energy costs, optimizing chemical use for treatment plants, and also in enabling proactive asset management. So we can see over the next 10 years, annual OPEX for water and wastewater utilities nearing $100 billion. Thirdly, water main breaks are costly for the utilities in both the financial and also social capital. So AI and machine learning can kind of fingerprint the data patterns that indicate breakout events that may be imminent and learn from those patterns so alerts can be more accurate over the length of time. So machine learning fits within operational performance management strategies. Also, operations no longer need to analyze complex variables for important decision making, for instance, by themselves. So whether it's turning a pump on or off, or determining whether chemical dosages, or deciding when to maintain assets. AI pretty much enables operators with intelligent recommendations and are often driven by machine learning. So we got planning, we got forecasts for future water demand, we got forecasts for peak flows, operations, we have equipment scheduling, we have predictive maintenance schedules. In terms of management, we have quantified potential non-revenue water based on leak analysis and check rates. And then also in terms of engineering, analyzing system capacities and levels of service, and then also forecasting water quality. Ultimately, solving control strategies for updated compliance limits. So, optimize energy use for, of course, drinking water and wastewater, energy self-assessment tools, energy audits for water and wastewater utilities. So according to the EPA, for many municipalities, governments, drinking water, wastewater plants are their largest energy consumers. I mean, often accounting for 30 to 40% of their total energy consumed. So that rolls up nationally to a large amount, which drinking water and wastewater systems, they account for approximately 2% of the energy use in the United States. AI can optimize pump run times so they're not only using energy when they need to, but this should be an easy cost reduction in terms of early adapters for AI. And then ultimately, we start talking about the idea of data centers, consuming water and helping ways to find them to use less. So that kind of efficiency for artificial intelligence promises water savings far beyond utility operations and water distribution. So, for example, the realm of water footprints for a data center. Data centers are becoming ever more of pervasive and need ever more energy to operate. They also need to build water cooling towers to cool the massive racks of servers that they build up these days, that they typically just set in giant warehouses. So, again, data centers have become massive users of water cooling racks, and AI can help address those things. Ultimately, meeting and fluent compliance standards also is a requirement for many organizations. So both public and private. And AI learns from the unique characteristics of your site to ensure that the fluent standards are met and compliance fees are avoided. So there's been an explosion because really we want to simplify data integrity. So we talked about the massive use of cooling racks, but we want to simplify data integrity. So there's been an explosion available of data and water operation managers that have kind of brought along the challenge of data management, SCADA systems, CMMS, and even social media hold a wealth of knowledge trying to improve operations. AI can take heterogeneous data and process it so that it's clean, it's useful, it's secure, and it drives high fidelity recommendations. AI also will retain institutional knowledge. So how do you ensure that a veteran or long-time operator, how do you ensure that their value, their knowledge is retained after they leave the workforce after several years? Well, AI-powered data cards can help in terms of the institutional knowledge and standardization. So, also AI will accelerate the move of value-based asset management. So early users or early adopters of AI are quick to react to asset maintenance behind. Time-based maintenance is easy to manage, but results in unnecessary uptime and detention or deterioration. So we let AI team up with all your assets and those that need to be serviced and win. So, as an example, Autodesk has put out this kind of,
Introducing the machine learning deluge tool inside of Autodesk InfoDrainage. Tailored to provide unprecedented speed, stability, adaptability, and interactivity in the assessment of flood maps, the tool quickly simulates a depth of water over a surface, generating a responsive flood map indicating locations of ponding and channeling on a given site. By leveraging our machine learning algorithms, this feature will lead to users being able to make responsive design changes. Like this example, where a drainage designer is adjusting the location of a pond and the flood map instantly responds, indicating how effective that change was. You can see now that with this change, the pond location captures all of the pooled water. This tool will make drainage designs more intelligent, responsive, and efficient.
So intelligent, responsive, and efficient. So that's just a quick preview of some of the functionality that's within InfoDrainage. And it kind of shows the interactive element of how you can move a pond around to get instant feedback in terms of flooding, flood maps, and the result of the change as we kind of move around. So again, faster site analysis. So InfoDrainage's machine learning tool can analyze and predict channeling and ponding, enabling you more informed decision making in the drainage design process. So you have like multiple updates in terms of what InfoDrainage has been. And with the new InfoDrainage, you're able to support drainage design, which is an essential part of a project that's in the build environment. Also, enhance model stability. So machine learning algorithms are not vulnerable to hydraulic modeling instabilities. Not this ideal of garbage in, garbage out. Great data in, even better data out to solve and establish where water is. Machine learning relies on spotting patterns, which is a stable process in which you ensure and locate the best possible positioning for your stormwater controls. Whether those are inlets, whether that's a detention pond, whether bioretention, just different options. So this tool kind of enables designers to kind of predict where your flood maps accurately, when applying water on a specific site surface, also while leveraging the ideal where you need to spend less time trialing stormwater controls. Instead, you can focus on creating sustainable and resilient drainage schemes. Scalability also in terms of.
Ray says he can't hear you. I can hear you well, but can you try to mute and unmute just to see if we can reset it?
Can you hear me now?
I can hear you. Ray, let us know in the chat if you can hear him now, please. All right.
Hey, Misty, I noticed at the bottom of my it says my screenshot has a strike through the mic.
That's fine. They should still be able to hear you though.
Okay. Is it only one person that's not hearing me?
Yeah. Yeah, and Ray, if you need to, you can try to refresh your browser at the top there. But anybody else, let us know if you can't hear. You can go ahead and keep on going.
Okay, so everybody can still see my screen, okay?
Okay, they hear. Yep.
Okay.
Yep. Okay.
Perfect. So, and again, faster site analysis, enhanced model stability, and then scalability. We'll see how this tool handles the various projects and just to kind of get a scope of what the interface looks like with InfoDrainage. And then iterative design. So kind of moving things around and they're interacting in real time modifications that allow your users to kind of get feedback as they're from flood maps or really understanding the impact of what's happening at your site location and what may be happening downstream. So you can implement improvements into your design. So let's make sure everybody's good here. And let me share my screen again because we'll make sure we got everything going here. Okay. So we'll give it a second. Okay, perfect. Just wanted to make sure everyone can see my screen and clearly, you don't need to be able to see me, but working with, this is InfoDrainage. So I'm just gonna turn my camera off so we can focus on InfoDrainage. So one of the things that we want to look at is this ideal of what we can do in terms of stormwater management. But the ideal of exceedance is to understand, what's happening maybe downside of the existing site that you're working with and what kind of impacts you'll be working with. So there's several things here in reference to what you can do with InfoDrainage. And as you can see, working with surface data, CAD data, GIS data, and imagery. So one of the things I want to be able to do is open up a file, and that file makes reference to a couple of things. So I got a detention pond, and I got some catchment areas, and I got some storm networks. So in terms of what we see on the interface, a lot different in terms of what you may be working with, specifically to those who have been using Civil 3D's HydroFlow storm sewers, Civil 3D's storm and sanitary analysis. So the first thing, just to kind of, again, get a feel for where we're at, similar to Civil 3D, down the left-hand side, you got a tree view that kind of shows you different items. And if you expand those items, you have more items within those items. And then just some nice tree view. And then we have this pull down views up at the top in terms of plan, importing data, rainfall data that we want to be able to, preliminary sizing, building tools, some analysis, and then results, and then the ability to export that data out. So just to kind of walk through in terms of what the interface provides for us. So in terms of what we have in terms of our model, not the typical model that you will see in the previous programs that's out there that you use, but in reference to a pond, something as simple as a pond. If I double click on my pond, and we'll wait a second here, because the dialog box comes up.
Can you reshare it?
Yes. Okay. So, and again, just the typical pond in terms of so the ideal behind, even our layout. So if I wanted to come in something as simple as showing a profile of my layout. So one of the things that is very, very beneficial to working with InfoDrainage is this ideal of what you get in terms of your layout. So let's see. So I'm going to move on from there and then kind of show these things on and off. But what we want to be able to do is we want to be able to create some analysis. And from my analysis ribbon, as you can see up at the top, from my analysis ribbon, I have certain criteria that I can create, certain analysis that I can validate. But under analysis criteria, it brings up a small dialog box in reference to my analysis criteria. And what this dialog box is giving me, it's giving me the ability to show what type of rainfall, what type of analysis, and specifically my rainfall events. So where those rainfall events are located, and right now you're not seeing it on the screen, but what type of rainfall events are being displayed. So from NOAA, SCS, EPA, XP Swim, we have all these different options that we want to be able to take a look at. So from that, just some really simple things. All I want to do is be able to tell it specifically what my rainfall event is going to be. And based upon my specific return period, I'm going to select a different rainfall event. So this is going to take a second, but we will be able to see specifically the results of my rainfall event. Okay, so I'm going to select OK. And from that, I'm going to come right over to my analysis. And hopefully you can see this part. And I'm going to say validate. So it brings up a dialog box, even though I can see on the screen that is not displaying my dialog box. So I'm going to run the analysis, and before I start out, I am going to load, just real simple, from the plan, from the import tab. I'm going to load a surface in. From loading this surface in, I'm going to select OK. And let's see. From this, I'm going to select OK. And I'm going to update all my elevations. And now I can see basically my surface that's been added in to my model. So we just had a network at first, and now I've added in a surface as my model. But one of the things we're able to see in terms of this machine learning and from this surface, we're able to do a deluge assessment. And by a deluge assessment, I really want to be able to open and assess specific data based upon my surface model. And from doing that, if I pick on and select open, I can go ahead and save this. And then the next thing I want to be able to do is, because all my data has been updated on my analysis tab, I want to be able to go to 1D and 2D analysis. From this, and again, you'll have to forgive me because my dialog box isn't coming up here, but I want to specify a criteria in reference to my analysis, and we'll be able to see the result from my analysis. So we'll just take a hot second. We'll select OK. And then what it does is it builds a mesh in reference to my analysis. So it's a couple things that have come up. This is showing me where the most evasive water and ponding will happen over my site. And I can do that over a 1 year, a 5-year event, a 20-year event, a 50-year event, or a 100-year event. I also can set my critical storm. So as you can see, there's different areas that, based upon my surface, that I'm able to open up. So down here, I can select my slope arrows in terms of where water is draining to. And from that, if I go down, because I've run this analysis, if I select play, this will actually calculate where water is starting to flood and drain to. And based upon this data, I can start making better decisions about where I want to place my catchments, maybe my detention pond in terms of specific areas. And this is, again, just some quick access in terms of how I want to start out. So flooding can be seen from several manholes. And again, all I need to do is play it, and I can stop it. We'll stop this in a moment, so I'll talk about this. So you can see flooding from several manholes and the flow downhill away from the road. However, it impacts at least one of the properties, and additional measures would need to consider south of the site, especially if further properties were placed down this road. So if I wanted to get a better idea, we can turn that surface layer off. And I can run that again so you can get a better idea in terms of flooding. So the ability to move things around and see real time, and the ability to be able to push this data out, not only from InfoDrainage, but directly into Civil 3D. So straight from my storm sewer design application, straight into Civil 3D. And as we kind of move around, so for a second here, as we kind of move around, I'm going to push this data so we can see what that looks like in Civil 3D. We can see actually what this looks like in 3D and from our plan. So if I zoom in, we can see our network, and the ability to pick on my network and plan to see my actual pipes and what's going on gives me a lot of flexibility per pipe, per catchment, per storm manhole. And the beauty of working with InfoDrainage, as I move this down, just as an example, I'm going to pick on this pond and drag it. Notice what happens when I drag this pond. Everything dynamically updates in reference to my site. So based upon that, let me turn my surface back on. We want to make sure that's on the surface. We also want to run that 1D and 2D analysis again. So I can run that 1D and 2D analysis again. So from that, now I'm collecting more water from my pond. And then we'll show that again. And again, as I move this around, again, here's my road. As I move this around, I'm able to display interactively. We'll run that again. And as soon as that comes up, just take my time there. And we can run that again. So interactively being able to move my pond during my analysis. Okay, so I'm going to come back. I'm not going to save this. And the beauty of working with also InfoDrainage is we have this button up here. It shows me undo, undo, undo. Real world scenarios. And I'll cut my surface back on. So I came all the way back. So what I want to be able to do is I want to be able to import this into Civil 3D to see what that looks like. So we'll take a second here. As it comes up, we'll be able to display. So the beauty of working with InfoDrainage, and again, this ideal of artificial intelligence in terms of what we're using in terms of some of these tools provides great advantage in terms of what we're looking at. So I'm going to start out. I'm going to move this screen, and this will take a second. And are there any general questions that we have kind of flowing out there?
We have a comment saying very interesting, but no questions.
Oh, okay. Okay. So, I'm going to share my screen again. This will just take a second. Okay. This should come up. Now, hopefully. Okay. So now we have Civil 3D. So what do we have in terms of Civil 3D? So some of the typical things, clearly storm and sanitary analysis and the hydroflow extensions. We also want the ability to pull in data from InfoWorks, InfoDrainage. So we have an Innovize ribbon, so I can import from InfoDrainage. So this will take a second, and it's looking. It says select my InfoDrainage file to import. Well, my InfoDrainage file to import, if I can find it here. And I'll go ahead and select next. And give me a moment here. And one more second here. Simple junction. Just make sure my part family. Come back. Give me a second here. In some way, somehow, in a moment, we can see our file brought in. So what does that actually mean? And it's going to pop up on the screen in a second. Well, a couple things. Straight from Civil 3D. So I'm just going to select a couple of these. In fact, we'll change this view Southwest isometric. So not only does it bring in, and hopefully this won't be a major thing in terms of what you all see, but we'll change this to shaded. That came out. That's nice. So not only does it bring in my catchment areas, it brings in my pipe network, it brings in my structures, it brings in, wow, my pond. From that, we'll come back to the top and we'll do 2 wireframe. From that, not only can I go there, I can come here and we'll take a look at it. We'll say create a network from network parts. So I'll pick here, and everyone should be familiar with this. And I'll hit enter. So not only that, but the ability to create. And we'll draw this in the profile view. And I'll just come in and plop it in right there. So here's our profile of our network, all the way down to the pond. And I haven't did anything but open my model in InfoDrainage, bring that model into Civil 3D. Hopefully we could see our dialog box with our pipe properties. Well, what properties come over? All my hydraulic properties. So my hydraulic properties, my part data, all that data comes over. Back and forth from InfoDrainage to Civil 3D. Seamless interoperability, back and forth. Here's my catchment area. On my catchment area, I can go into my catchment properties. From my catchment properties, it's giving me my data and information. Time and concentration, user defined, 5 minutes. I can use TR55 if I wanted to. So my design parameters that I use from InfoDrainage straight back into Civil 3D. My parameters from Civil 3D straight into InfoDrainage. So not only the ability to pull from InfoDrainage, but to also export. So the ability to import from InfoDrainage and then export from Civil 3D to InfoDrainage. And again, all still using and coming back to the ideal of AI and the solutions that it brings to the table in reference to efficiency, productivity. So again, from this slide here, I'm going to stop this share for a second, just for a second. So ultimately, and that should be coming up, ultimately, AI and its machine learning deluge tool, faster site analysis, InfoDrainage's tool can analyze, predict, channeling, ponding, similar to Civil 3D if we take the time and create a surface based upon that surface, run some analysis with slope arrows and slopes and grades and elevations. InfoDrainage also enables you to have more informed decisions by your drainage design process. Also, enhanced model stability. I can go from Civil 3D into InfoDrainage, also into InfoDrainage, from InfoDrainage into Civil 3D, and also InfoDrainage has machine learning algorithms. And based upon those algorithms, clearly, based upon those algorithms, we're able to make more decisive. So not only modeling instabilities, equations that solve to establish where water is going to be. Where is water going to flow to for my 1-year storm, for my 10-year storm, for my 25-year storm, for my 100-year storm, and ultimately my critical storm? How is that affecting my site? So we got these patterns that AI recognizes to have this stable process that's going to ensure where's the best place a user, designer, or an engineer should be placing these stormwater controls. Also, scalability, efficiency, with various scales from a residential to a large commercial project. InfoWorks addresses all those. InfoWorks addresses the storm water side. InfoDrainage addresses the sanitary side. So there's a lot of, back and forth. And during that back and forth, this iterative design, this tool allows for moving stormwater controls that automatically update dynamically as you're moving them around the site. Real-time modifications. So now, not the need to run that process, run the report, review the report, check to see if it's within the scope of parameters. Not only that, now you can encourage your users to make changes at will, get instant feedback, flood maps, understanding the design impacts, and the idea of implementing improvements to your design. That makes us, one, more productive, more efficient, a better return on the software that you're using. And with the ideal of artificial intelligence and this machine learning tool, the deluge tool that they have within InfoDrainage, gives us a great advantage over all the other applications that might be out there. So we kind of review the 10 different ways that ultimately we could take advantage of machine learning and AI. So artificial intelligence, it's really making its mark on specifically the water industry, because we're in civil infrastructure, and then allowing operators who use this machine learning to optimize resource use and operational use, which ultimately affects operational budgets for many consultants or organizations out there. So it's kind of changing the way the water industry is, from business innovations that save money and make more efficient, because there's global changes and they're happening fast. And clearly, based upon those global changes, we have challenges in terms of lowering overall water consumption. And these are just some of the tools that will allow us to do that. So I am open to questions.
Awesome. All right. So while we wait for any questions, I did put on the stream here. If you'd like to learn more about GRAITEC training, you can just click the button on the screen. And let's see if we've got any questions. I don't have any as of yet. And I will put my email. If you guys think of any questions after the webinar, you can reach out to me. I'll get you connected with the right person with the right answers. So I'll just throw that in there. Very, very interesting webinar today, Kenneth. Thank you so much.
You're welcome. And if anyone wants to do an online meeting to talk about these things outside of this time, we could schedule to do that one-on-one if you wanted to. If you have questions or concerns, or you want to see just some different things that InfoDrainage and AI can address.
Absolutely. AI is taking over everything for sure. Could be a good thing, if you know how to utilize it correctly. So
Indeed.
We do have a question from Victor. He says, what will happen if the input for MI will be changed in 10 years? I don't know if I'm reading that correctly. What will happening if the input for MI will be changed in 10 years? That out?
That out. AI only recognizes and addresses the data that you put in and run algorithms to filter the data in terms of what you're putting in to make a decision. So in 10 years, maybe around, and maybe not. But as of right now, these are just some of the things that it addresses. And clearly there's a lot of AI in different environments out there.